So we did example 1 and 2. Now we're going to do example 3 and 4 before we go on to the complex fractions on the other page. So you guys remember what needs to be true in order for you to add and subtract fractions.
What
does that mean?
The
The least common denominator. They both need to have a denominator that looks the same. How do we find the common denominator? Factor first.
And then you put it over in that wherever the denominator is missing.
Multiply times that?
Yeah.
Okay. Yes. So let's go ahead and do the process for finding the common denominator first. So, hold on. We don't have to worry about the numerator to start with. Right, how would I factor the first denominator? It's a trinomial, so I'm going to use the x. So what should go in the top of the x? Negative 10. 3. So what two numbers multiply to get negative 10, but add to get a 3? No. Negative 2, positive 5. Because you want the 3 to be positive. Now, can I use that shortcut we were talking about before?
Yes.
Why?
Because the leading coefficient is 1.
The leading coefficient is a 1, so I'm going to write x minus 2 and x plus 5. Do I have to worry about the denominator for the second fraction?
No.
No, that can't be factored. Alright, so once you guys factor the denominators, you want to look to see what you have, and you're going to write one representative of each factor that we have in the denominator. So it's one of the factors that we have.
X plus 5.
Okay, so we have x plus 5, it's twice, but remember you only write it once per pair, and then x minus 2. So our denominator is supposed to look like that right there, x plus 5, x minus 2. So what's one nice thing that they've done for us in this situation? They've already given us a fraction with the common denominator, but the other one doesn't have that common denominator. So what am I going to have to do? I'm going to have to multiply this one by the x minus 2, the piece it's missing. So let's rewrite the first fraction without changing it. Don't need to worry about that one. Alright, but in the second fraction, I have the x plus 5 part, but I was missing the x minus 2. So I'm going to multiply top and bottom by x minus 2. Alright, so remember, in order to work with these fractions now, we're going to try to combine like terms in the numerator, but we can't do that until after we've distributed or FOIL, whichever one that you have to do in that particular situation. So the first numerator I can leave alone, right? But if I'm going to combine this into one fraction, what do I have to do in the top of the second fraction? I have to distribute the 2, right? So I need this to be actually multiplied through so I can combine my terms. But this one, there's something very important you guys have to pay attention to. The minus. See how this is subtraction? So when I'm distributing, am I distributing a positive 2 or a negative 2? I'm distributing a negative 2, okay? Because of the fact that it's a subtraction. So when I distribute, it's going to be minus 2x, but then plus 4. And then you would write on the denominator. Alright, so that's something incredibly important to look out for. If it's subtraction, and you guys are distributing, you do have to distribute that subtraction sign with the number as you're going through that process. FOIL, if it was a FOIL situation, you'd have to FOIL first and then distribute the negative throughout it after you do the FOIL. So you guys do have that extra step to pay attention to if it's subtraction. So make sure you're really, really careful. Alright, now what? Combine my terms. So if I do that, what would the top look like? 7. And then the bottom has my denominator. Now remember in the previous example, what do you have to check for before you actually say this is your final answer? Do all your work to add, you get here, and you want to see if you can simplify a little bit more. Is there any factoring I could do in the top? We took care of the factoring in the bottom early on. Once you get the two fractions together, you want to see if you can factor the top. Is there anything I can do with the numerator? No. So that would be my final answer. can't simplify, then you just leave it. That is the 2. Alright. So for the restrictions, do you guys remember where those come from? Restrictions come from the denominator. And your denominator the denominator they're talking about for the restrictions is the common denominator. So how would I find the restrictions? You set them equal to 0, right? So you get -5, oops, and 2. Those are going to be your restrictions. Alright, so does anybody have, I'm sorry that happened. That's kind of weird. Where's my pointer? Okay, there's my pointer. Cool. Alright, so is everybody okay with that example? See how that one worked? Alright. What about this guy? Let me extend the screen a little bit. Alright, what would I have to do first? Anytime you guys run into a situation and you notice it's addition or subtraction, what should you do first?
The top.
You want to, what are we going to do? Right out the top? Okay. Okay. Then what?
There's a triangle.
So a little bit more broadly.
X minus 1. So you want to do the X.
Okay, so you keep the x minus 1 because we can't factor it. Once you write out the top, so the next step is to factor. So we can't factor the first one, but I can factor the second one. All right, so what would go in the top of the x? A 2? What about in the bottom? Okay, so two numbers that multiply to get positive 2, but add to get negative 3. -2, -1. Can I use the shortcut for factoring? Y. Leading coefficient is a 1. So I have x minus 2.
Which was Which was
Yeah, if I did that, it would actually mess it up worse. I'm not going to do that. Yeah. Alright, so what were our factors again? Okay, well you guys know what to do. Go ahead and write that down while I exit out. There we go. Excuse me. Alright, so then what would the LCD be?
X minus 0, X minus 1.
Alright, so we have the x minus 2 and x minus 1. You write each factor that you see once. You want to represent each factor. Alright, so what's another nice convenient thing that they've done for us in this example? What? We don't cancel in addition.
So the minus
One of the fractions already has the common denominator, right? So you don't have to, don't ever cancel an addition or subtraction until they're combined first. Right? So this one already has the LCD, but what about this one? I'm going to use the x minus 2, so what am I going to do to fix this problem? Multiply the top and the bottom times what you're missing. So, in this fraction, in the first one, I'm going to change colors. I'm going to multiply top and bottom by x minus 2. But the second fraction was fine, so I don't have to change it. I'm just going to write it as is. And it really doesn't matter what order you guys put the factors in. If you have them swapped in each fraction, it doesn't really matter. Alright, so what am I going to have to do? Remember, I have to combine like terms in the numerator. So in order to do that, what do I have to do first? I'm going to have to distribute so that I have a string of monomials that I can actually combine. So what would the top of my fraction turn into? X squared. Let's keep going. Plus 2x minus 1. I like to do the distribution or FOIL and write them as one fraction at the same time, but if you want to split it up into 2 steps, that's fine. Alright, so I've combined them and taken care of any extra work I need to do in the numerator. Now what do? Combine like terms, so I get x squared. Those cancel each other out, right? And you have a minus 1 here. and you have x minus 2. Right? Now that it is one fraction, this is where I can now check to see if there's anything I can simplify or cancel. Is there anything I can do from here? Can you factor this? Yeah, those are perfect squares, right? So I can turn this into x plus 1, x minus 1. This. And then what happens? These guys cancel. Their final answer is just the x plus 1 over x minus 2. Alright, so again, whenever you guys finish the addition or subtraction, that's great. You did the process perfect, that's great. But you always have to make sure at the very, very end, once you get one fraction, you double check to see if there's anything you can factor in, cross out. Alright, restrictions. Those come from the denominator before you canceled anything, so the LCD. So what are the two numbers that would not be permitted in my domain? 2 and 1. You set both of the factors in the denominator equal to 0, so you change signs when they come out of the parentheses. Right? So everybody okay with those 4 examples that we practiced with the addition and subtraction? Questions? Okay. On the next page, we have our complex fractions. So you guys are probably not going to see these very often on the SOL. The ones that you guys would see would be the 4th example at the very, very bottom. The ones that we've seen before with the KCF, where it's just division. But these ones, I think you see them a little bit more in pre-calculus, so that would be a good foundation. And you work with them the same way as we just did with addition, subtraction, and then throw division into the mix. So we're going to practice these, and I think there's a couple on homework, but I'm pretty sure there's none on the test. There's one on the quiz, though, but there aren't any on the test. Alright, so what we're going to do is with this complex fraction, we're going to pretend that we don't have the denominator for a second. Right? We're just going to work with the numerator and add those two fractions together so that it's one fraction instead of 2. And then we're going to go to the denominator and do the same thing. So you're going to work with the numerator and denominator separately, one at a time. So you're going to combine those two together, and then once you have that, it'll look like example number 4. It'll just be fraction divided by fraction, and you guys do KCF, just like we did on day 2. Okay? So it's like addition, subtraction, and division all wrapped up in one question. Alright, so I like to do this. So I'll run really long fraction bar, and I'm going to work with the top only, right? So I have over here LCD for the numerator and LCD for the denominator, because they will have different common denominators. So if you ignore the bottom for a second, what would be the common denominator for the numerator, the 2 and the 4? 4. So I'm going to grab that down. The common denominator for the numerator should be a 4. How do I make both of them have that denominator? Okay, so this would be 2 over 4 if I multiply that times 2. And what about the second fraction? That one's okay. And it already has the common denominator. Alright, and if I combine those, what do I get? 5 over 4. Alright, so we simplified the top. Now we're going to do the same thing in the bottom. What would the LCD be? Sounds weird. What would the LCD be for the denominator if you have the 5 and the 3? 15. Right? Remember the common multiple, the least common multiple of those two numbers? So I need the denominator to be 15. How do I make the first fraction have a denominator of 15? Times 3. So 18 over 15. And how do I make the second fraction have the denominator times 5? So 10 over 15. And then I'm going to subtract those. 8 over 15. Alright, once I've done this should look a little bit more familiar. We did this on day 4. When we did the division problems. This is a division represented vertically. You guys need to be able to recognize division represented vertically. We have a fraction divided by a fraction. Do you guys remember what the 3 letters are that are going to tell us what to do?
Something.
Yeah, it is something. What are the something?
With a flip at the end.
Okay. KCF. Keep, change, flip. Anytime you guys see a division question, it's keep, change, flip when you are dividing fractions. So what am I going to keep? I'm going to keep the first fraction. What do I change? change to multiplication, and then what do I flip?
Only 15 already.
Yes. Once you have this, it should look a little bit more familiar. This is what we practiced on day 4. Now I need to multiply these. And remember, to multiply, you're going to cross out anything that you can cross out, and then multiply whatever is left over. So is there anything I can cross out top bottom?
No.
No, the 5 and the 15 don't divide with the 8 or the 4, so there's nothing I can cross out. So we're just going to multiply them together. So 5 times 15 is 75. And that's 32. So your answer would be 75 over 32. Alright, that's a complex fraction. Alright, now if they ask you for restrictions, what would you say for this one?
The opposite. There are none.
There are none. Right? The only reason why we would have restrictions is if you would plug in something to get a 0. Can I even plug in anything? Are there any x's? No. If there are no variables, there are no restrictions, because there's no way to get a 0 in the denominator. They're clearly going to be a number, so you don't have to worry about dividing by 0. Okay. Next one. Again, we're going to just look at the top for a second. So this one's interesting because they've written a fraction and then a non-fraction, right? When they do that, you want to turn the non-fraction into a fraction. So how can I write 4 as a fraction? Right, 4 over 1. That will make it a little bit easier for us to understand what's going on here. So one of the denominators is a 3 and the other one's a 1. What would be the common denominator? 3. So for the numerator, the common denominator is 3. How do I get them both to have a denominator? First one's okay, right? Other one times 3, so it's going to be 12 over 3. Okay? And if I were to combine those, x minus 12 over 3. When they're not like terms, so if you have like a variable and a number in different fractions, because they're not like terms, you just write them together as a subtraction. Brigham and Justin. There we go. Follow along, please. Write down what you missed. I'm not going to scroll up. We can figure it out. They're going to do work by themselves if they're sleeping. Alright, so we took care of the numerator, now let's do the denominator. So this is another non-fraction. How can I rewrite that to help us? Over 1. Okay, so what would the LCD be for the denominator? X. Because they have the 1 and the x, so the numerical part is a 1, and then the variable is just x. So how would I... Well, they both have to have the denominator of x, though. Multiply times x. So what would my first fraction look like? Oops. 5x over x plus 1 over x. That was a little bit more abstract, right? If you're trying to, because, see how this is 5 over 1? Their denominator needs to have an x in it. So what we're missing was the x. You multiply top and bottom by x. So you're going to have 5x over x. And then if I combine those, what would I have? 5x plus 1 over x. Alright, so now we've made this look more familiar. The other complex fractions we talked about with division look like this. So if you have fraction divided by fraction, what are you supposed to do if it's division? Keep, change, flip. Anytime you guys see a division, it's keep, change, flip. Once you have your one-to-one relationship. So what am I going to keep? Okay, keep the first fraction. Change to multiplication. Okay. Is there anything that I can factor here? Is there anything that I can factor? We can factor this. How would I factor that if I can? No. Can't factor anything, guys. There's no GCF. There's no trinomials. There's no perfect squares. You can't factor anything. Can I cancel anything? Can I take this 12 and divide it with that 3? No. Even if you wanted to, you cannot. Right? Remember, you cannot cancel things unless you factor first. Right? See how this is subtraction? Right, the subtraction is locking these two in place. You can't divide if the operation is subtraction. You can only divide if the operation is multiplication, which is not happening. okay? So you cannot cancel anything until after you factor, which we can't do. So what do you think the final answer would look like if you can't cancel anything? So what would the top be?
Oh, yeah. X squared minus 12.
Okay, if you distribute, which you are not necessarily required to do, right? It's x times x minus 12, so you can distribute. And then the bottom. If you're going to distribute the top, then you have to distribute in the bottom. So I honestly don't know if the SOL is going to show it to you in the distributed or non-distributed format. So if you write it in the non-distributed format and the answer looks different, they probably distribute it. So just be aware that there are different ways of representing that answer. But that's what your answer would be. All right, what would the restrictions be? Remember for division, remember the shoe or the moccasin? I can't remember which we talked about. Or the boot, whatever. For my fourth period called them the moccasin. Whatever, fine, it's a slipper. Right, you have to look in all three of these positions in order to find restrictions. We didn't have any up here because we didn't have variables, but these definitely have variables. So what would my restrictions be? This doesn't have an x in it, so that doesn't give me anything. This gives me a 0 because it was a monomial. This one, if I set that equal to 0, negative 1, okay. Because you have to subtract the 1 and divide by 5. You set equal to 0. So it's negative 1 and 5. Okay, everybody see how we did that one? Yep. Alright. What would the common denominator be for the numerator? This one has an x and this one has a 2x. It's 2x, right? You have to have the numerical part and the variable. Remember, if they have a variable, you just pick the one that has the higher power. They're both just x to the 1. So. Alright, so what do I have to change? Multiply the first fraction times 2. So it's going to be 2 over 2x plus 3 over 2x. If I combine those, what do I get?
5 over.
Yep, 5 over 2x. Alright, what's the common denominator for the bottom fractions? I have a 3 and a 4. With those two, you have 12. And then they both have an x, so you have to have 12x. Remember, when they're monomials, there's no factoring. You just have to consider what's going on with the numbers and the variables. Okay, so times 4. The other one's times 3. Everybody see how I work with the denominator there? Okay, now I need to combine them. 4 plus 9, 13. Yep. Now remember, you don't need to have the denominators the same top and bottom. Right? You can have different denominators in the numerator and the denominator for division. Right, so when we do division, what am I supposed to, right, the KCF. So I keep the first fraction. What do I change? Times. Okay. So we have a monomial situation here. So in order to cancel, we don't have to factor if it's monomials, because they're all multiplication, right? It's either a standalone number or they're automatically multiplication. So we can go ahead and start canceling things for the monomial situation. Is there anything I can cancel? 2x and 12x? So the 2x goes completely away, right? And then what's left behind with the 12x? Yeah, because the x's cancel and then you divide by 2, so the 2 goes away and then there's a 6 left over. No more x. So what would be left in the numerator? 5 times 6, which is, and then the denominator, this turned into a 1 technically. So I have 1 times 13. 30 divided by 13. What would the restrictions be? Oh, there are restrictions. There were x's. Remember, restrictions come from before you cancel, not after. Right, so even though all of the variables disappeared in the final answer, since we had variables before we started canceling things, we do have restrictions. They're all monomials, so what would the restriction be?
0.
Right? So that's how you guys work with the complex fractions. You need to combine the numerator, combine the denominator, and then use your KCF like we were practicing on day 4. This is the complex fraction. I just want to remind you guys, this is what you guys would see more often, right? Where you already have the top combined and you already have the bottom combined. You just have fraction divided by fraction. This is more likely what you guys are going to see. This is a division question, and it's presented vertically, which I believe on the test, that's all that they do. If you have division, usually if it's multiple choice only as well, they will present it vertically, like this. You just need to recognize that this bigger division means, or sorry, this bigger fraction bar means divide, okay? So, if I see this, what would I do? This is a division problem. What do you do when it's division? You change flip. Right? Remember, when it's just multiplication, they're already set up where you multiply, that's where you go straight into factor and cancel. But if you have divide, where it's represented this way, you're going to have to do KCF first. Right? So what am I going to keep? The first fraction, so 3x squared plus 7x, minus 3 divided by x squared minus x minus 6. And then what does the C stand for? I'm going to change the multiplication and then flip the second fraction, or the one on the bottom, so it becomes 3x over 18. We always do this first when you guys see a complex fraction that's already been combined in the top and the bottom. Just get down some more room. Alright, so everybody see how we did that? Alright, now we're just going to proceed like we normally do for multiplication. What do I have to do from here? Factor, right? Because I can't start canceling things until I factor first. So I'm going to have to factor this using the x. Alright, so what would go on the top?
-9.
-9. And then the bottom? 7. Remember, you have to multiply first and last. Right? So what multiplies to get -9 but adds to get 7? I wonder if anything even does that. Oh! I didn't like this example. Okay, I forgot that I put this in here. Are there any numbers that multiply to get -9 but add to get 7?
No.
No. So this one is a unique situation where I cannot factor the top. So I want to make sure you guys saw it. Okay, so you can't factor that, but can I try factoring the bottom one?
Yeah.
Okay.
-6.
Okay, so are there any numbers that multiply to get -6 but add to get -1? It's -3 and +2. Right? Yeah, that's right. Alright, so as we're working through this, the top part cannot be changed, but how do I factor the denominator? Can I use a shortcut?
Yeah.
Yeah, so it would be x minus 3, x plus 2, times 3x over 18. Right? Now that I'm here, I factored everything that I could. What would I do to try to simplify it? There's very little we can do, but there actually is some. Cancel this 3x with that 3x squared? No. First of all, they're both in the top. You can't cancel when they're both in the same space within the fraction. One needs to be in the top and the bottom. Say one more time. The 3 and the 18. Can't you divide those as like a unsimplified fraction, 3 over 18? Can't I divide something evenly from those? What can I divide from both 3 and 18? 3. So I would just leave nothing behind, but what would be left here? 6. Okay, that's pretty much all I can do, right? There are no just x factors that I can cancel. I can't take anything from here because this is addition and subtraction instead of multiplication, so I can't touch anything in the top anyway. So your answer is going to look a little bit weird, but this is what you would have left over. You have the x from this factor, and then you're just going to rewrite this as is.
We don't even have this common.
Say one more time.
We don't even have these common in common.
But you don't need that for division or multiplication, remember?
Oh,
You only need a common denominator for addition or subtraction, and that's not what's going on here. This is just division. Alright, and then this would be x, and then x minus 3, x plus 2. And it's a little bit weird looking, but sometimes you can't factor. So don't assume that you can factor every time. Sometimes you can't factor even when it's a trinomial. So make sure you're looking out for those. Alright, what would my... Oh, I didn't even need these. I left those there on accident. So I changed this to example before I printed out the notes. Alright, we don't have to worry about the numerator and denominator, common denominators, because we're not actually adding or subtracting anything. But we do need to worry about restrictions. So what would my restrictions be? Remember we're looking at the slippery one, I guess is what we're calling it. So this one gives me a restriction of 3, -2, and 0, because we have the monomial up here. Alright, so it's a little bit weird, but again, that's what you would do. So when you guys see division, when you guys see a complex fraction, if you see 1, 2, 3 different division bars, that's when you guys have to use KCF. Anytime you're doing division of 2 fractions. Alright, and again, you're not going to see these. You're not going to see these on the test or the SOL. I'm like 95% sure. But there is one on the quiz this lesson, and there are a couple on home. Alright, so does anybody have any questions about that? No? Long time. Everybody has any questions?
Show me 0.
No, there's no question now. Alright, there are no questions? This is like the weirdest lesson. Everybody's okay with it? Okay. Alright, so yes, you guys do have the homework, so my recommendation is to do it now since it's fresh. Or at least do like maybe one of each so you have an example if you're going to save it for later. Although, it is a little bit dangerous because we do have an extended break, so you guys aren't going to have your quiz until the 21st, which is quite a long time between now and then. So, I mean, you guys think about what you want to do, how to do the homework now, and you can study it, or maybe do one example and finish it later. I don't know. Whatever you guys think would be best for you. Since our quiz is not going to be for like 1, 2, 3, 4 days, 4 or 5 days. Alright. Stop the video.